example A. Example A, calculate the torque produced by a 50 Newton perpendicular force at the end of a 0.2 meter long wrench. The formula for torque we write like this. Torque is equal to perpendicular force times the distance of the lever arm. The variable that represents torque is kind of like a t. We can't use this lowercase t as our variable because what is this the variable for? Time. If we were to use an uppercase t like this, what is this the variable for? Temperature.
So it's like an M on an L.
So instead we use this Greek t, and this is the variable for torque.
It's like an M on an L.
It's like a T with a squiggly top. Alright. So perpendicular force is 50 newtons times the distance of the lever arm, that's 0.2 meters. 50 times 0.2 is 10. And then the SI unit for torque is the Newton meter. Yeah, the Newton times meter. Okay, so just for review, what is the formula for work? Work equals what? This was on your test Friday. Work is force times distance. Okay, good. Torque is also force times distance. But torque is the perpendicular force times the distance of the lever arm. What is the SI unit for work? Not watt. It's the joule. All right, the SI unit for torque is not the joule. It's the Newton meter. So they're similar, but they're different. Example B. Calculate the torque produced by the same 50 Newton force when a pipe extends the length of the wrench to 0.5 meters. All right. So torque is given by 50 newtons times 0.5 meters. That's going to be 25 Newton meters. So is that more torque? Yeah. So we get more torque for the same amount of force if we just extend the length of the lever arm. That's 50 newtons.
Oh, it looks like it.
Looks like S.
All right, here we have a scenario with a seesaw. And the whole length of the seesaw is 6 meters. The fulcrum of the seesaw is right in the middle. So from that, we can assume that this girl is sitting how far on the seesaw?
3 meters.
3 meters.
Yeah.
All right. And we don't know how far out the boy is sitting.
3 meters, he has to be.
If you're sitting on 3 meters, he'd be.
The girl is applying 300 newtons of force. The boy is applying 600 newtons of force. We have a balanced torque situation here. The torque on one side of the seesaw is equal to the torque on the other side of the seesaw. So torque 1 equals torque 2. Okay, calculate the individual torques produced by the weights of the girl and the boy on the seesaw. What is the net torque? Well, if torque 1 is equal to torque 2, then all we have to find is torque 1 in order to get the individual torques. So torque 1 is equal to force 1 times distance 1. The force of the girl is 300 newtons, and the distance that she's sitting on the seesaw is 3 meters. 300 newtons times 3 meters is 900 newton meters. So that's the value of each individual torque. To the first part of the question, what is the net torque? The net torque is equal to 0 because they're balanced and they're not moving. Because they are not moving. And then example D continues this problem. Calculate the distance a 600 Newton boy should sit from the fulcrum. So now we're looking for this unknown distance. And force 1 times distance 1 is equal to force 2 times distance 2. Force 1 times distance 1 we found to be 900 Newton meters. Force 2 we know to be 600 newtons. And distance 2 is unknown. All right, so how are we going to find distance 2? We have to divide out 600 newtons. Whatever we do on one side, we have to do on the other. So we divide out 600 newtons here. Cancel 600 newtons and cancel newtons. And then the unit that we're left with is the meter. 900 divided by 600 is 1.5 meters is equal to distance 2. The most difficult problem on this worksheet is going to be number 4. And number 4 is just like examples C and D.